So welcome to today's class. Today we will be discussing with the chemical equilibrium. So what is chemical equilibrium? Chemical equilibrium is a phenomenon. It is the characteristic property of reversible reactions. It is the characteristic property of a reversible reactions. What is meant by reversible reactions? Reactions in which conversion of the reactants into products, products into reactants take place simultaneously under similar conditions of temperature and pressure. So, what are the important theoretical aspects regarding the chemical equilibrium? So, we can expect theoretical questions in the chemical equilibrium topic are characters of equilibrium constant, relation between Kc and Kp, and units of equilibrium constant. So, what are the characters of chemical equilibrium? When chemical equilibrium is established, we observe no further change in the concentrations of the reactants or the products with the time, as long as external conditions are maintained constant. How to recognize the attainment of chemical equilibrium? By the constants in observable properties like pressure and color intensity. Equilibrium can be approached from either side, that is, a state of equilibrium can be established by initiating the process with either the reactants or the products. So, equilibrium can be disturbed by changing the conditions like concentration, temperature and pressure. And what is the nature of the equilibrium? Nature of the equilibrium is considered dynamic, because even after the equilibrium is established, continuous activity in the form of two opposing reactions, namely forward and backward reactions, take place simultaneously with equal velocities. That is why nature of the equilibrium is considered dynamic. Now, what are the important constants of the equilibrium? What are the important characters of the equilibrium constant? Equilibrium constant remains constant as long as temperature is maintained constant. Change in conditions like temperature, pressure, concentration and volume of the vessel will disturb the equilibrium, but not the chemical equilibrium constant value. So, chemical equilibrium constant can be expressed in two ways, in terms of molar concentration, in terms of partial pressures. What is the relation between them? Kp is equal to Kc into RT to the power of delta N. What is delta N? Number of moles of gaseous products minus number of moles of the gaseous reactants. Higher values of Kc and Kp indicate that the greater extent of the forward reaction. Now, changes in the values of Kc or Kp with change in the stoichiometry. Suppose if a new equilibrium is produced, if equilibrium 2 is equal to equilibrium 1 multiplied by n, then what will be the equilibrium constant for the new equation? K2 will be equal to K1 to the power of n. What is n? N is equal to coefficient of a substance in equation 2, by coefficient of the same substance in equation 1. N takes negative values if the substance under consideration is on the opposite sides. This is one important. Next, if the resultant equation, if equation 3 is equal to equation 1 plus equation 2, then resultant equilibrium constant will be K3 will be equal to K1 into K2. If equation 3 is equal to equation 1 minus equation 2, equation 1 minus equation 2, K3 will be equal to K1 by K2. K1 by K2. These are the important characters of the equilibrium constant. And one more thing is, at equilibrium, change in free energy delta G will be equal to 0. Delta G will be equal to 0. So catalyst has no influence on the either equilibrium or equilibrium constant value, because catalyst accelerates both forward and backward reactions to the same extent. Let us consider two important equilibria. PCl5 gives us to PCl3 plus Cl2. PCl3 plus Cl2. This is the type of the A gives us to B plus C. A gives us to B plus C. For this, alpha value is equal to root of Kp by Kp plus P. What is alpha stands for? Degree of dissociation. For this type of the equilibrium, A gives us to 2B, alpha value will be equal to Kp by Kp plus 4P. And what is the example for this type of the reactions? N2O4 gives us to 2NO2. These are the two important relations. When PCl5 undergoes 50% dissociation, then what will happen? When PCl5 undergoes 50% dissociation, then Kp will be equal to P by 3. Kp will be equal to P by 3. And one more popular equilibrium, NH4HS gives us to NH3 plus H2S. NH3 plus H2S. For this equilibrium, Kp will be equal to P square by 4. P square by 4. Now, another important, these are the important relation which students are advised to remember as far as the chemical equilibrium is concerned. Now there is another important point, reaction coefficient. What is meant by reaction coefficient? Ratio of products concentration by ratio of reactant concentration at a given time t. So what is the relation between the reaction coefficient and the equilibrium constant? If Q is less than Kc, to establish equilibrium, Q value must be increased. That is, products concentration should increase, which can happen only when forward reaction is favored. So when Q is less than Kc, to establish equilibrium, Q value must be increased. That can happen only when the product's concentration is increased, which is possible only when forward reaction is favored. So let us take the reverse case. When Q is greater than Kc, this happens when products are added. This happens when reactants are added to the equilibrium mixture. When Q is greater than Kc, what will happen? Again, the system will be disturbed. To attain the equilibrium, Q value must be decreased, which can happen when the product's concentration decreases, that is, when the backward reaction is favored. So the remaining concept will be explained through the numericals. Come on, question number 1. See here in this case, what is the question? Which is considered the most stable oxide? They have given the dissociation constants. So the stability of the oxide is inversely proportional to the dissociation constant value. Lower the dissociation constant value, greater is the stability. So, if the equilibrium constant value is dissociation constant value is high, implies that the oxide is not stable. That is why it is undergoing dissociation to a greater extent. If Ka value, dissociation constant value is more, what does it imply? The oxide is getting dissociated to a greater extent, which can happen when the oxide is unstable. So, when the dissociation constant value is less, implies that the dissociation of the oxide is taking place to a lesser extent, implies that that oxide is stable. So, here in this case, stability of the oxide is inversely related to the dissociation constant. Nitric oxide has the low dissociation constant, hence it is considered to be the stable oxide. Option 2 is the answer. Next, active mass. What do you mean by active mass? Nothing but concentration, molar concentration, N by V, which is equal to P by RT. N by V is equal to P by RT. P by RT. P by RT. At STP, what is the P value? 1. What is the P value? 1. What is the RT value? 22.4. Because R value is 0.0821 into temperature 273 will be equal to 22.4. N by V, active mass is equal to N by V, which is equal to P by RT, which is equal to 1 by 22.4. Next question. Kc for N2 plus O2 gives us to 2NO2 at certain temperature is given as 1.6 into 10 to the power minus 3. Then Kp for NO gives us to of N2 plus of O2 at the same temperature. Now, what is the point? What is the point? Equation 1 is N2 plus O2. N2 plus O2 gives us to 2NO. This is the equation 1. What is the equation 2? What is the equation 2? NO gives us to of N2 plus O2 here. Of N2 plus of O2. Of N2 plus of O2 here. So, here equation 2 is equal to equation 1 multiplied by minus of. How do you get it? How I got that? Coefficient of NO in the first equation by coefficient of the NO. Coefficient of NO in the second equation by coefficient of the NO in the second equation. N is equal to 1 by 2. Why it has taken negative sign? Because NO happens to be on the opposite sides. So, K2 will be equal to K1 to the power of minus 1 by 2, that is 1 root K1. So, Kp for the new thing is K2 is equal to, what is K1? 1 by 1.6 into 10 to the power minus 3. 1.6 into 10 to the power minus 3. It can be reorganized as 16 into 10 to the power minus 4. That is 1 by 4 into 10 to the power minus 2. So, it will be 25. Next, initially 0.8 moles of PCl3 and PCl5 and 0.2 moles of PCl3 are mixed in 1 liter vessel. So, PCl5 gives rise to PCl3 plus Cl2. PCl3 plus Cl2. PCl5 gives rise to PCl3 plus Cl2. What is the initial number of the moles? 0.8, and for PCl3 it is 0.2. At equilibrium 0.8 minus X, this will be 0.2 plus x, this will be x, this will be x. Now what is given for us? Hint: at equilibrium 0.4 moles of PCl3 is present. At equilibrium, number of moles of PCl3 is equal to 0.2 plus x, which is equal to 0.4, implies x is equal to 0.2. Now what is the Kc? Kc value is equal to, this is 0.4 into 0.2 by 0.6, 2 by 3, 0.4 by 3, 0.4 by 3. Option 1 is the answer. Next. Next, for a hypothetical reaction, equilibrium constant values are given. So, A gives such to D. How we are getting this equation? A gives such to D. Equation 4 is equal to equation 1 plus equation 2 plus equation 3 plus equation 3. Therefore, K4 is equal to K1 into K2 into K3, which is equal to 2 into 3 into 4, 24. Option 3 is the answer. Next. One mole of CaCO3 is heated. When CaCO3 is heated, we get CaO plus CO2. CaO plus CO2. CaO plus CO2. In 11.2 liters, that equilibrium is established at 819 Kelvin. If Kp for at this temperature is 2 atmospheres, what is the equilibrium concentration of the CO2? See here, what is the Kp value? Kp is nothing but pressure of the CO2, that is equal to 2 atmospheres. What is the question? Equilibrium concentration. N by V is equal to P by RT. How do you get concentration? Number of moles by volume in liters. Number of moles by volume in liters. P by RT. What is P value? 2. And what is the temperature? 819 Kelvin. 819 Kelvin. 0.0821. I write 819 as 273 into 3. 273 into 3. So 2 by 22.4 into 3, 1 by 33.6, 1 by 33.6. Option 3 is the answer. At 819 Kelvin, it is heated in 11.2 liters. Yes. P by RT, P by RT. This is the answer. 1 by 33.6 is the answer. Now, what is the reversible reaction take place in 2 steps, 2 and 3, with equilibrium constants 2 and 0.45. So here what is the as given in the problem, equation 1 is equal to equation 2 plus equation 3. Equation 1 is equal to equation 1, equation 2 plus 3. When we add equation 2 and equation 3, we will get equation 1. Therefore, K1 is equal to K1 into K2. K1 into K2, which is equal to what is K2? K1 2 into 0.45, 0.9, 0. Option 1 is the answer. Next, for the reaction A plus B gives such to C plus D, initial concentrations are equal. A plus B gives such to C plus D. Since they said that equilibrium initial concentrations are equal, we can assume anything we like. Let initial concentration is 1 and 1. At equilibrium it is 1 minus x, this is 1 minus x, this is x and x. What is given? The equilibrium concentration of C is half of the initial concentration of A. So x is equal to 1 by 2. What is given? What is given? Equilibrium, it is equilibrium concentration of C is half of the initial concentration of A. What is equilibrium concentration of this? X, which is equal to half of this. X is equal to 1 by 2. Then what will be happen here? 0.5, 0.5, 0.5, 0.5. Kc will be equal to 0.5 into 0.5 by 0.5 into 0.5, which is equal to 1. Option 1 is the answer. Next, 20 grams of CaCO3 is allowed to dissociate in a 5.6 liters container at 819 degrees centigrade. If 50% of CaCO3 is dissociated at equilibrium, what is the Kp value? Kp's value is nothing but pressure due to CO2. CaCO3 gives us to CaO plus CO2. CaO plus CO2. What is the Kp value? Pressure due to CO2. How do you get pressure due to CO2? nRT by V. nRT by V. nRT by V. Now, 20 grams of CaCO3 is allowed to dissociate in a 5.6 liters container. 50%, what is the initial concentration? CaCO3 gives us to CaO plus CO2. Initial it is 20 grams. Initially it is 20 grams. This is 0, 0. And finally it is 10 grams. 10 grams. When 10 grams is dissociated, when 10 grams of CaCO3 is dissociated, we will get 4.4 grams of CO2. When 10 grams of CaCO3 dissociates, we will get 4.4 grams of CO2. Now, what is the question? Number of moles of CO2 is then, number of moles of CO2 is equal to 4.4 by 44, that is 0.1. Now, Kp is equal to, pressure, Kp is equal to pressure due to CO2 is equal to, what is N? 0.1. What is R? 0.0821. And what is 819 degrees? That is 819 plus 273. 819 plus 273, 1092. I write 1092 as 4 into 273 by what is the volume? 5.6. So this will come to 22.4 into 0.4 by 5.6. So it comes to around 1.6. Option 2 is the answer. Next question. In the reaction A plus 2B gives such to A plus 2B gives such to A plus 2B gives such to 2c plus d, 2c plus d. What is the information given? The initial concentration of B is 2 times of that A, but equilibrium concentrations of B and C are found to be equal. Then what is the Kc value? Let the initial concentration of A is 1, so B is double that of A, 2, 0, 0. At equilibrium it will be 1 minus x, it will be 2 minus 2x, it will be 2x, it is x. What is the given hint for us to calculate the x value? At equilibrium, concentration of B is and C are equal. 2 minus 2x is equal to 2x, that is 4x is equal to 2, x is equal to 0.5. Now at equilibrium this will be 0.5, this will be 1, this will be 1, this will be 0.5. Now Kc is equal to 1 square into 0.5 by 0.5 into 1 square. Kc is equal to 1. Option 4 is the answer. This is the way. What is the hint given for us? At equilibrium, the concentrations of B and C are equal. So initially, concentration of B is twice the concentration of A. Next question. We'll move on to the next question. At a certain temperature, the degree of dissolution of the PCl5 was found to be 0.25 under a pressure of 15 atmospheres. What is the value of Kp for the dissolution of the PCl5? So PCl5 gives rise to PCl3 plus Cl2. PCl3 plus Cl2. Since nothing was specified, this is 1, this is 0, this is 0. And at equilibrium, this will be 1 minus x, this is 1 minus x, this will be x, and this will be x. What is the hint given for us to calculate the x value? What is the hint given for us to calculate the x value? X is equal to 0.25 of 1, 0.25 of 1, that is 0.25. So it will be 0.75, it will be 0.25, it will be 0.25. Now what is the mole ratio? Mole ratio is equal to 3:1:1. What will be the mole fractions? For PCl5, 3/5, for this 1/5 and 1/5. Now how to get the Kp value? So mole fraction of PCl5, 1/5 into 15 into 1/5 into 15 by 3/5 into 15, 3/5 into 15. So 115 gets cancelled out, 15 gets cancelled out. It will be Kp will be equal to 1. Kp will be equal to 1. Option 1 is the answer. So when degree of dissociation is 0.25, what will be left over? 0.75, 0.25. Mole ratio is this, mole fractions is this. By definition, Kp is equal to mole fraction into total pressure. Next question. N2O4 gives rise to 2NO2. N2O4 gives rise to 2NO2. N2O4 gives rise to 2NO2. The degree of dissociation at equilibrium is 0.2 at 1 atmosphere. Then Kp will be, let the initial concentration is 1, this is 0. At this 1 minus x, this will be 2x, this will be 2x, but x is equal to 0.2, x is equal to 0.2. How we got this? alpha is equal to number of moles dissociated by total number of the moles taken. Total number of the moles taken. So it is 0.2 x by 1. So x is equal to 0.2. X is equal to 0.2. Now at equilibrium, what will be this moles? 0.8. And what will be this moles? 0.4. What is the mole ratio? 2:1. What will be the mole fractions? 2/3, 1/3, 2/3, 1/3. Then Kp will be equal to 1/3 into 1 whole square by 2/3. So 1/9, that is equal to 1/9 into 3/2, 1/6. 1/6. Option 3 is the answer. 1/6. So this is the basic definition of the alpha. So number of moles dissociated by total number of moles taken. Number of moles dissociated is x, total number of moles taken is 1. So x is equal to 0.2. Next. A vessel at 1000 Kelvin contains CO2 with a pressure of 0.5 atmospheres. Some of CO2 is converted into CO on the addition of graphite. What is the value of K at equilibrium when the total pressure is 0.8 atmospheres? So what is the equation? CO2 plus C gives us to 2CO. CO2 plus C gives us to 2CO. What is the initial concentration, initial pressure? 0.5 atmospheres. 0.5 atmospheres. This is 0. At equilibrium, this will be 0.5 minus x. This will be 2x. So, but 0.5 minus x plus 2x is given as 0.8. That is x is equal to 0.3. X is equal to 0.3. Now, what will be this thing? 0.2. What will be this thing? 0.6. 0.5 plus x is equal to 0.8. So, x will be equal to 0.3. 0.3. So, what is the question? The value of Kp at equilibrium. Value of Kp at equilibrium. So, Kp is equal to partial pressure of CO square by partial pressure of CO2. What is the pressure due to CO here? 2x means 0.6 into 0.6 by 0.2. So, 3, 1.8. 1.8. What is the delta 1? 1.8 atmospheres. Option 2 is the answer. Next. .2 moles of SO3 were allowed to dissociate in a 2-liter vessel. The reaction is 2SO3 gives rise to 2SO2 plus O2. 2SO3 gives rise to 2SO2 plus O2. 2SO2 plus O2. So initial moles 1.2 moles 0 0 at equilibrium 1.2 minus 2x 1.2 minus 2x 1.22 minus 2x and this is 2x, this is x, this is x. But what is the point? At the concentration the concentration of oxygen at equilibrium is 0.1 mole per liter, 0.1 mole per liter. But the volume of the vessel is volume of the vessel is 2 liters. So in 2 liters, what will be the oxygen present? 0.2 moles. 0.2 moles. 0.2 moles. Oxygen will be 0.2 moles. Oxygen will be 0.2 moles. Right? Now, what is the total number of the moles? What is the total number of the moles? 1.2 minus 2x plus 2x plus x. 1.2 plus x, but x is equal to 0.2. 1.4, because x is given for 0.1 mole per liter. In 2 moles in 2 liters vessel, it will be 0.2. So total number of the moles will be 1.4. Option 2 is the answer. Next question. Kp values for 5 atmospheres. What is the equilibrium partial pressure of O2 if the equilibrium pressures of SO2 and SO3 are equal? What is the expression for Kp here? What is the expression for Kp here? Partial pressure of SO3 square, partial pressure of SO3 square by partial pressure of SO2 square into partial pressure of O2. Since they are equal, so Kp will be equal to 1 by partial pressure of oxygen. Partial pressure of oxygen is equal to 1 by Kp, that is 1 by 5 is equal to 0.2. Option 1 is the answer. Next question. NH4HS, the total pressure is NH4HS gives us to NH3 plus H2S, NH3 plus H2S. For this type of the equilibrium, what will be the Kp value? P square by 4, because this is solid. At equilibrium, this will not be taken into consideration. At equilibrium, what will happen? This will be x moles. This will be x moles. Mole ratio will be equal to 1:1. So mole fractions will be equal to 1/2, 1/2. And what will be the Kp value? Partial pressure of NH3 into partial pressure of H2S. So 1/2 into P into 1/2 into P, which is equal to P square by 4. And what is P value here? 30. What is P value here? 30. Kp is equal to 30 into 30 by 4, which is equal to 225. 225 atmosphere square. Option 2 is the answer. This is a, we can remember for this, because this is an important equilibrium. What is the Kp value for this equilibrium? P square by 4. Next. A vessel contains N2O4 and NO2 in 2:3 molar ratio at 10 atmosphere pressure. What is the Kp value for N2O4? N2O4 gives us to NO2. What is the mole ratio? Mole ratio is 2:3. Mole ratio is 2:3. So mole fractions will be equal to 2/5, 3/5. Then Kp is equal to 3/5 into 10 into 3/5 into 10 by 2/5 into 10. 110 cancels out, 15 cancels out, and Kp will be equal to 9. Option 2. Because here delta n is equal to, what is units for the Kp? Atmospheres to the power of delta n. Atmospheres to the power of delta n. In this problem, what is the delta n value? 1. So option 1 is the answer. never get confused. For the option 2 is atmosphere to the power of -1, that is delta n is -1. It is not -1 in this case. What is the delta n value? 1. So what is the unit for Kp? Atmospheres to the power of delta n. So what is the delta n here? 2 minus 1, 1. So Kp is equal to 9 atmospheres to the power of 1, not -1. So option 1 is the answer. Next question. So this is an important point. Kp1 and Kp2, x gives such to 2y, x gives such to 2y, x gives such to 2y. For this type of the equilibrium, alpha is equal to Kp1 by Kp1 plus 4p, Kp1 by Kp1 plus 4p. And what is the other equilibrium? Z gives rise to P plus Q, P plus Q. For this type of the equilibrium, alpha is equal to Kp2 by Kp2 plus P. This is similar to PCl5 gives rise to PCl3 plus Cl2. This is similar to N2O4 gives us to NO2. Since these two are the two important equilibria, we have given this expression. Now what is given here? Alpha 1 is equal to alpha 2. Degree of dissociations are equal. Alpha 1 is equal to alpha 2. And what is other things they have given? Kp1 by Kp2 is equal to 1 by 9. What is the thing they wanted? What is the thing they wanted? P1 by P2 is equal to how much? P1 by P2 is equal to how much? Since alpha 1 is equal to alpha 2, so since Kp1 by Kp2 is equal to 1 by 9, I put 1 in place of Kp1 and 9 in place of Kp2. And alpha 1 is equal to alpha 2. So 1 by 1 plus 4p1, 1 by 1 plus 4p1, since alpha 1 is equal to alpha 2. So this square root goes off. 1 by 1 plus 4p1 is equal to 9 by 9 plus P2, 9 plus P2. So simplifying it, P1 by P2 will be equal to 1 by 36. Since these two equilibria are repeated equilibria, just I thought of giving these two relations. Kindly make a note of this. Next option is 4. Next, look once again, what is the relation between alpha and Kp value for this type of the equilibrium? This is the relation. What is the relation between alpha and Kp value for this type of the equilibrium? This is the relation. Please remember. Next, in a 500 ml flask, the degree of dissociation of the PCl5 at equilibrium is 40% and the initial amount is 5 moles. What is the value of the equilibrium constant for PCl5? So PCl5 gives us to PCl3 plus Cl2 plus Cl2. What is the initial number of the moles? 5, 0, 0. What is that equilibrium? 5 minus x, x and x. What is the degree of dissociation? 40%. So alpha is equal to 0.4. 0.4 is equal to x by 5. So x is equal to 2. So this will be 3. This will be 2. This will be 2. And what is the volume of the flask? Kc is equal to 2 by 0.5. into 2 by 0.5 by 3 by 0.5. Number of moles by volume in liters. Volume in liters. 4 into 4 by 6 by 6. So 2 by 3, 8 by 3, 2.66 is the answer. Option 2. Right. Next, move on to the next problem. NH4HS. Just now we have discussed about this equilibrium. For this equilibrium, NH4HS giving rise to NH3 plus H2S. NH3 plus H2S. What is the Kp value? P square by 4. Kp value is equal to P square by 4. 100 is equal to P square by 4. So P square is equal to 400. P is equal to 20. P is equal to 28 pounds. Option 3 is the answer. Move on to the next question. XY2 gives rise to XY2 gives rise to XY plus Y. XY plus Y. What is the initial pressure? 800 0 0 0. When it comes to the final at equilibrium, 800 minus x, x. So what is the total pressure at equilibrium? At equilibrium, total pressure is 800 minus x plus x plus x is equal to 960. 800 plus x is equal to 960. X is equal to 160. Alpha is equal to pressure decrease in the 160 by 800. 160 by 800. X by total mole. So decrease in the pressure by total pressure, total number of the moles. So number of decrease in the pressure corresponds to number of moles dissociated, and total pressure corresponds to the initial concentration. 160 by 800, it will be equal to 0.2. Option 2 is the answer. Next, one mole of A is heated 200 A till the following equilibrium is reached. See, this is nothing but character of the equilibrium. What is the character of the equilibrium? Velocity of the forward reaction is equal to velocity of the backward reaction. When equilibrium is reached, what is the character of the equilibrium? At equilibrium, velocity of the forward reaction is equal to velocity of the backward reaction. Option 3 is the answer. Next, AB2 dissociates into AB plus B. What is the initial pressure? 500. Initial pressure is 500, and 0 500 minus P. What is the value? At equilibrium 500 minus P plus P is equal to 700. So P is equal to 200 mm. Now what will be the Kp value? 200 into 200 by 300. 400 by 3. 400 by 3. What is the vessel? 400 by 3. 133.3 mm. Option D is the answer. Next question. The first and second dissociation constants are the overall dissociation constant of the acid is equal to Ka will be equal to K1 into K2 because the dissociation of the acid takes place in 2 steps. Overall dissociation constant will be equal to K1 into K2, which comes to 5 into 10 to the power minus 15. Option 2 is the answer. Next, NH4HS gives rise to NH3 plus H2S. NH3 plus H2S. So the process is started with 0.5 atmospheres of ammonia. So initially this is 0.5 and this is 0. At equilibrium it will be 0.5 plus X. This will be X. At equilibrium what is given? 0.5 plus X is equal to 0.84. Therefore X is equal to 0.17 atmospheres. X is equal to 0.17 atmospheres. What is the Kp value? Partial pressure of NH3 into partial pressure of H2S. Partial pressure of H2S. What is the partial pressure of ammonia at the equilibrium? What is the partial pressure of ammonia at the equilibrium? 0.5 plus X, 0.67 into 0.17. It comes around 0.11. Option 4 is the answer. Next, so PCl5 gives rise to PCl3 plus Cl2. PCl5 gives rise to PCl3 plus Cl2. So what is the initial number of the moles taken? 2 moles are taken. 2 moles are taken. 0, 0, 0, 0. Next, at equilibrium, this will be 2 minus X, X, X. What is the total? Sigma n will be equal to 2 minus X plus X plus X is equal to 2.53. It must be 2.2. It is wrongly printed. Okay. 2 minus X plus X plus X, 2.53. So X is equal to, X will be equal to 0.53. X will be equal to 0.53. So alpha is equal to X by number of moles dissociated by total number of the moles taken. So X by initial number of the moles taken, total number of the moles taken, 0.53 by 2. 0.53 by 2. Next, what is the final pressure of the system? A vessel contains at 2 atmospheres. See, the degree of the dissociation of N2O4 at equilibrium is 0.2. What is the final pressure of the system? N2O4 gives rise to 2NO2. N2O4 gives rise to 2NO2. Let the initial pressure is 2 atmospheres. At 2 atmospheres, 0, 0. and at equilibrium pressure due to N2O4 is 2 minus x and this will be 2x, this will be 2x, this will be 2x. What is the x value? 0.2 and 0.2 of 2. So x value is equal to 0.2 of 2. X value is equal to, how to get x value? Alpha value is 0.2, x by 2, x is equal to 0.4. This will be 1.6, this will be 0.8. Total pressure will be 2.4 atmospheres. So how to get the x value? Alpha is equal to x by total initial pressure. So x is equal to 0.4. So pressure due to N2O4 will at equilibrium will be 1.6. Pressure due to NO2 will be 0.8. What will be the total pressure? 2.4 atmospheres. Next question. The number of the moles of the components. How do you get number of the moles? N is equal to PV by RT. N is equal to PV by RT. What is the pressure? 4 atmospheres. What is the pressure? 4 atmospheres. What is the volume of the vessel? 22.4. What is the R value? 0.0821. What is the temperature? 273 degrees centigrade means 546 Kelvin. We can write it as 2 into 273. 2 into 273. 0.081 into 273 is 22.4. So 4 by 2, it is 2. Next. Vapor density of PCl5 is 104.16, but heated to 230 degrees centigrade, its vapor density is reduced to 62. What is the degree of dissolution of PCl5 at this temperature? This type of the problems can be solved using the Van Hoff's factor. What is the relation between Van Hoff's factor and the degree of dissolution? Alpha is equal to I minus 1 by n minus 1. Here, when PCl5 dissociates into PCl3 plus Cl2, what is the n value? 2, because 1 mole is on dissociation is giving rise to 2 moles. So alpha is equal to I minus 1. So how do you get I value? Theoretical molecular weight by experimental molecular weight, which is equal to 2 into theoretical vapor density by experimental vapor density. 2 into experimental vapor density. So 2 gets cancelled out. What is the theoretical vapor density? 104.16. What is the experimental vapor density? 62. What is the experimental vapor density? 62. So alpha is equal to 104.16 by 62 minus 1. This is alpha. If you want the percentage, multiply with 100. It's around 53 or something. 68%. Next. What is the percentage dissociation? So same model. Here this is also same model. Vapor density of N2O4 is 46. Theoretical vapor density for this is also I is equal to theoretical vapor density is 46. Experimental vapor density is 30. So what is the value? I value is 1.53 and alpha is equal to 1.53 minus 1. So 0.53. It is 53.3%. Option 1 is the answer. Next. Thank you very much. We'll continue in the next class.